So what is the importance of studying the shrinkage and swelling behavior of the wood? As I told, dimensional changes associated with shrinkage and swelling may cause degrade in the timber products. So that to reduce the degradation, we have to control the shrinkage and swelling behavior of the wood. As a result of shrinkage and swelling, different types of defects which can be shown in the wood are the opening or tightening of the joints. When furniture is there, and because of the change in the weather condition, sometimes we might encounter that our furniture, the joints are loose. This happens because of the shrinkage or swelling of the wood. And then changes in the cross-sectional shape of the wood. Then warping takes place because of the difference in the radial and tangential shrinkage. Similarly, checking small cracks appear on the cross section and on the sides surfaces. That is because of the moisture gradient from the core to the surface of the wood. So wood can be twisted or it can be disshaped. These are the different types of defects like twist, bowing, crooking, cupping. This may happen because of the faulty seasoning behavior of the wood. So wood should be seasoned in a proper way. Then only these types of defects can be avoided. Now, based on this shrinkage and swelling behavior, we can calculate what is called the retention of the shape index. And based on the retention of shape index, the wood have also been classified like the woods which are liable to warp and crack. The retention of shape is less, like 50 to 60 only. And these are the examples here, like eucalyptus falls under this category. Then liable to hair splitting and cracking, this is 61 to 70. And sal comes under this category. Moderately steady and steady timber and very steady timber. Very steady means when this retention of shape index is more than 90, like undulata, Tacumala undulata, and gamari, that Melena arborea. These are the timber species which are classified as very steady timber. Then next is the color, amount of hardwood present, grain, texture, and figures. These are already been discussed. And here we know that wood comes in different colors. Even white woods are available and very dark color woods are available. So depending upon the our choice, we can select the wood for different applications. Then it is the hardwood which is mostly having the commercial value. The hardwood is the inner colored wood which is present in the tree. So if hardwood is higher in quantity, means the tree will fetch more value. Similarly, the grains which appear on the surface and their texture and figures are very important while going for different applications. Next is the mechanical properties of the wood, like behavior of the wood under applied forces. When we apply the force on the wood, how wood is going to behave, how strong is the wood, that those kind of properties are being studied under mechanical properties. So these are mechanical properties listed here, and they we are testing them as per the Indian standard, what is called the IS 1708 1986. These are the different mechanical properties like static bending, strength, impact bending strength, compressive strength parallel to grain, compressive strength perpendicular to grain, hardness, shear strength, tensile strength, cleavage, nail and screw holding power, brittleness, torsional strength. These are the different mechanical properties. So we have to study all these properties to determine how strong is the wood under different types of load applications. Like static bending, we apply the load on the center of the test sample, and then we have to plot the stress versus strain curve or the load versus deflection curve. And when load is beyond a certain point, the wood sample will break. This point is called the point of rupture. And what is the load at that point? We have to take that into account to calculate the modulus of rupture. Similarly, wood being a viscoelastic material, it behaves up to certain extent, certain limit as elastic material, and after that it becomes viscoelastic. So we can calculate from this elastic limit the what is called the modulus of elasticity. Here are certain formulas which are used for calculating the different static bending parameters, like modulus of rupture, modulus of elasticity, fiber stress at the limit of proportionality, work to proportional limit, and works to maximum limit. These are the as per the Indian standards. Similarly, we have to study what is called the compressive strength parallel to grain. When wood is being used like a column, then these kind of properties are very important. When load is applied parallel to grain structure or parallel to fiber direction. So load acts along the fiber axis, trying to shorten of the wood dimension. And compressive strength parallel to grain is greater than compressive strength perpendicular to grain. When in case of perpendicular to grain, the load is applied 90 degree to the direction of the fibers. So here are the formulas which are used for computing the maximum compressive strength, modulus of elasticity, and compressive strength as the limit of proportionality. And the different size of samples are taken for compressive strength parallel to grain as well as compressive strength perpendicular to grain. 20 by 20 by 80 is for parallel to grain, and 20 by 20 by 100 mm is for the perpendicular to compression perpendicular to grain strength. Then next important property is the shear strength. When one small piece of wood is shearing against the other piece, then we have to apply the load, and how much load is being applied to shear them apart comes under the shear strength parallel to grain. And this figure shows how shearing takes place. Similarly, tensile strength parallel to grain and perpendicular to grain. So these are the formulas here to compute the shear strength as well as tensile strength of the wood. And for all this, we are using the universal testing machine. It is called the Universal Timber Testing Machine, UTM. And using different types of fixtures, we can test the wood as per the Indian standard. So weight to weight, wood is stronger than steel in case of tension parallel to grain. When we test the wood, then this kind of comparison we can make. Then here what is listed is the physical and mechanical properties of the Tectona grindis as well as Acacia aquiformis wood in two different conditions. One is the green condition when moisture is very high, like it is around 76%, and air dry condition that is around 12%. And we can see that many physical and mechanical properties of the acacia wood are either comparable or better than teak. So it is teak which is naturally durable and it is good in looking. So that is why teak is much in demand. But Acacia aquiformis is also a good timber and it can be used in many applications in place of teak. So these are the other properties like hardness. You can see hardness in three different directions: radial, tangential, and end. Then maximum shear parallel to grain, and tensile strength perpendicular to grain, nail and holding screw power. And so different applications, different end users require the study of different properties. This is the table which shows the end use and correspondingly which type of properties are required to be tested. So for construction, these are the properties which we have to test, like shrinkage, static bending, tensile strength, compression parallel, compression perpendicular, and shear parallel. These are the properties which are absolutely needed to decide whether a timber can be used for construction or not. Similarly, for flooring, we have to study what is called shrinkage, hardness, and static bending. For furniture, these are the properties required: weight, shrinkage, and static bending, impact bending, tensile strength, compression parallel to grain, and nail and screw holding power, because furniture many times you have to use what is called the nail and screws. Packing cases, these are the different properties which are required to be tested. Then pallets, sports goods, tool handles, these are the different applications and different properties which are to be conducted. And this is other way around. The static bending is required for these are the different end uses, like for general engineering construction, doors and windows, aircraft, railway sleepers, agricultural implements, and compression parallel to grain, like for furniture, aircraft, tool handles. And then hardness of the wood, this like flooring, railway sleepers, sports goods, bodybuilding. And based on these properties, which are generally measured in two different conditions, that is green condition and air dry condition, we have to compute what is called the suitability indices of the a particular species. Here, teak is generally given as an index number 100, and based on teak as 100, we have to compare the other wood property suitability indices. And these suitability indices are like strength as a beam, stiffness as a beam, suitability as a post, shock resisting ability, retention of shape, shear, surface hardness, splitting coefficient, nail holding power, and screw holding power. These are 10 different types of suitability indices. Here, I have shown the suitability indexes for the acacia coliformis wood of two different ages, 8-year-old and 13-year-old. Teak is taken as 100. So we can see here many of the wood properties are better than teak, because teak is 100. So if something is more than 100 means it is better than teak, and it is less than 100 means it is inferior to teak. So acacia coliformis wood, many properties are better, but few properties are inferior to teak wood. These are the graphs which shows the variation in the different types of different suitability indices. So like rosewood, we can see the bar is at 100. So many that histogram bars are going above the 100 means these suitability indices for Dalbergia latifolia are better than teak. Similarly, this is for Andaman Podok. And this is neem wood, that's indica. So neem wood, like weight is better than teak, and then nail holding power is better than teak. Hardness is also slightly better than teak. Then mango wood, and based on this strength as a beam, the woods are also being classified in different categories, like very weak timber, moderately strong timber, very strong timber, and extremely strong timber, when strength of the beam is greater than 131. When strength of the beam is between 111 and 130, then it is called the very strong timber. So this is also a kind of classification. And then finally, we have to compute what is called the suitability figures. And these are the different sectors, application sectors, where wood is to be recommended finally for usage, like furniture, construction, wooden flooring, tool handles, composite sleepers, light packing cases, ammunition boxes, oars and pedals, door windows and shutters, pallets, and this kind of information has to be included in BIS. What is the number is 1399, zonal distribution of the timber for different end uses. So these are the main applications of the wood, and based on their properties, we can recommend the wood for different applications. Like for wood furniture, different timber species are classified in 4 different groups. One is the super group, second is the group 1, group 2, and group 3. These are the different strength coefficient and weight as taken teak as 100, and then the grain texture, finish, polishing appearance, and then we have given the examples of the different timber species. So this kind of information is available in IS 13622, 1993. So here we can see that few timber species fall under the supergroup, where strength coefficient is greater than 75, and the grain structure is very excellent. Like rosewood, sissu, paddock, teak, they are the species which comes under the supergroup, whereas the group 3, the strength coefficient is greater than 50, and different woods which comes under this are the fir, kadam, neem, eucalyptus, cheer, and 34 other species have been listed. Here, the importance is that timber should be seasoned to moisture content around 12%, and sapwood of all durable species and timber of durability class 3 should be preservative treated as specified in IS 401. So any sapwood has to be treated so to make it more durable. And these are the properties which are required for the construction, and the IS 3629 covers for this. So here also these 3 different groups are there: group 1, group 2, and group 3. And these are the parameters which are required in terms of modulus of rupture and modulus of elasticity. And then doors and window shutters, these are the different species, and 4 different groups are there: supergroup, group 1, group 2, and group 3. And if modulus of rupture, that is bending strength, is greater than and falling in the range of 88 to 102, then we can say that wood belongs to supergroup. And if it MOR is between 56 to 60, then it belongs to group 3. Then door frames, group 1, group 2, and group 3 similarly have been classified. And apart from the mechanical properties, we have to also see the working quality or working properties of the timber, like how it is easy to work the wood, and how it is what are the different quality woodworking parameters of the wood, like turning, boring, planing, sanding, carving, and ease of working and polishing, because these are required for not only for wood working by the carpenters, but also for aesthetic appearance. And we have classified the wood what are these parameters for different species, like Acacia coliformis turns well, bores well, and planes to a smooth finish. They are also sand well. Carving is very easy and very good, and polishing takes lacquer polishing well. So similarly, all the species which are generally being used for furniture and for handicrafts, they have to be classified under woodworking qualities. And these are the different timber species which our institute has studied, and they have been recommended for different applications. So for constructions, we have recommended many timber species. And similarly, for furniture, like Acacia coliformis, we have recommended Sotonia mahogany and Tecumseh undulata, Torcopus delbergis, Grevillea robusta. And agricultural implements, sports goods, Acacia coliformis, Morus alba, Mangiferine species, then pit sprout. These are the different important sectors in which wood is being used. And then handicrafts, because a lot of demand is there for handicraft sector as alternate wood species, because the primary timbers are not available much as required by the handicraft clusters. So we have studied many species and recommended for the usage as an alternate species for handicraft purpose. So Acacia coliformis, some of the pictures shown here, Acacia mangium, they have been, we have produced many usable items for demonstration that this timber species can be used for many applications. Eucalyptus camaldulensis and Tecumseh undulata, it is a very stable timber and being used much for the handicraft purpose. And Simurba glauca, this is also called the Lakshmi Taru. This timber is also very light and whitish in color and can be used as an alternate for the handicraft applications. And it is also naturally durable, like termite resistance. So, and thank you very much. This is all about the wood properties and different utilization using wood properties. Thank you.